Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. So today's problem is about acceleration and about acceleration formulas, obviously. So we have the train that moves along this line, and at some point, no matter where, we have the last car that is detached. So the train moves with a constant speed v0, and the last car starts with a speed v0 because it just detached, so they move together, and then it has an acceleration a. And then the distance between them grows and grows and grows, like, you see it in the movies, the last car of the train further and further away, and eventually it goes distance d and stops. And so this is the last car here, and the train obviously goes a little bit further. Let's put it S. The train goes S and the car goes D. And so we want to know what is relation between S and D. They don't ask us about what S is, what D is, but S versus D. So basically they ask us about this ratio. And probably it's very simple to obtain, but let's do it. So this is X, this is V0, and this is A. So A would be negative. So first of all, S is the distance that the train travels with a constant speed, and of course it's S V0 t. It's some time when the car stops. At the same token, D is the distance that car is traveling. And this is this formula that you either remember or memorize, or you remember how to derive this formula. It's a good time to pause this video, go to the previous problem, and to see how you derive this distance for the car that travels with the constant acceleration. And after you recover this, it would be V0, because it starts with the same speed, it goes for the same time t, and here you put minus. Minus because A is directed against the x. V0 is directed this way, that's why it's comes with a positive sign. But A directed this way, so it comes with a negative. Okay? And so we don't know much here. We know V0, T, we don't even know those, and all S is unknown, D is unknown, but as always they don't ask us about many things. They ask about these relations, about this ratio. And by the way, what else can we say? What is the specific about this moment in time t when this car stops? There are always two equations about the speed. One is about distance and the second about the speed. The speed of the car at that moment is 0, and because the car was traveling with constant acceleration or deceleration in this case, the formula for the speed that we will use, v equal v0 plus at, and another formula is d equal v0t plus at squared divided over 2. This we already used, so let's use this one. The moment when it stops, it's 0. 0 equals v0 plus, it's minus, because it's directed that way, minus at. And so this is three equations. Physics stops here, and fortunately it's very easy to do. For example, from here, we immediately obtain V0 equal AT, right? And immediately we can put this V0 in those two equations. The first becomes S equal V0T, nothing happens. Or we can put AT if we want. V0 is AT and multiply by T. Instead of V0, we put AT multiplied by T. And the second equation becomes D equals, instead of V0, we put AT, so AT multiplied by T, minus AT squared over 2. Okay? So it becomes two equations, and I work with those. AT, it becomes AT squared, and this becomes AT squared minus AT squared over 2. So this becomes AT squared over 2. And it becomes very simple. We can actually divide this over this, and a lot of things will go away. So let's divide. S over D, S over D, and this would be AT squared, divide over AT squared over 2. This is gone, and this becomes 2. So S over D becomes 2. So we can say no matter what, this distance that the train will travel will be double the distance that the car will go and stop. And this is very simple. It's based on the formulas, but let me show you even simpler way of doing things if we do it graphically. And for that, all I want to do, I want to draw the graph. And of course it would be the graph of V. And this would be T. So this would be the moment when the train and car are decoupled, detached. And this moment, the train will be continuing going until this moment, let's put it T0. It will be going with a constant speed, and it would be train. And this would be V0. Fantastic. Well, what happens with the car? This formula will be applicable. V equals V0 minus AT. Okay, so this is V0 because this is when T equals 0, V becomes V0, and at the moment in the beginning, the train and the car have the same speed, so its initial speed during acceleration. Then minus AT, that means it would be directed down. And this is the moment when the speed would become 0 when the car stops. So I have to connect those things. So this is the beginning, and this is the end of the car movement. Because when car stops, the last car stops, this is this moment T0 that we have. And at that moment it stops. And so now, let's recall what they're asking. They're asking about D and S, or S and D. So basically, D is the distance that's covered by the car. This is this area. And the distance, the S, so this would be D. And S would be the total area. The total area of this rectangular. Just looking on this picture, we know that S over D equals 2. That's it. And it's much more simple than to operate with those formulas. So it's graphical solution. And again, it's based on the fact that the area under the graph of the speed over time is the distance that body covers. So, conclude this problem. Don't forget to subscribe. Don't forget to bell. Don't forget to like. Don't forget to put your questions, put your comments. And if you have an interesting problem that you can think may be valuable for other viewers, please submit it in your comments. and if I think that it's interesting, I will put it in special playlist that I called from our users. Thank you very much. See you next time.